Hello everyone, welcome to Math or Stat 3379, Statistical Methods in Practice. Now let's look at Chapter 1. Chapter 1, Basic Ideas. In this chapter, we have 4 sections. Section 1.1, Sampling. Section 1.2, Types of Data. Section 1.3, Design of Experiments. Section 1.4, Bias in Studies. Before we look at section 1.1 sampling, let's first define what is statistics. Statistics is the study of procedures for collecting, describing, and drawing conclusions from information. In brief, we have 2 big areas for statistics. First, we have descriptive statistics. And then we have the inferential statistics. Let's now look at this data set. So what information can you get from the values below? We already have a couple of seconds reviewing the information, but we don't think that we can get any information directly from a lot of numbers right here. So then that's why we need descriptive statistics. Descriptive statistics consists of collection, organization, summarization, and presentation of data. So for descriptive statistics, we have 2 ways to present the information. One way is called graphical way, and another way is called numerical way. So the graphical way consists of graphs, charts, tables. In numerical way, we have averages, variance, percentiles, and so on. So for graphical way, this is a very famous histogram. So if we look at the histogram, that represent the information from the previous slide here, then we can know some information from those numbers. So all of most of the data values are stay around 0, right? Because we have a very high bar here. That means more counts around 0. And then as the numbers away from 0, we have less and less counts. So this histogram, which we will learn in chapter 2, this histogram tells us that we have a lot of numbers that they are all around or stay close to 0. And let's look at the numerical method. Average. We can actually calculate the average of all the numbers here. So after the calculation, we got the average equals negative 0.15. So this is also a number close to 0. So either way, we'll get some information out of this data set. Okay, that's descriptive statistics. Before we move to inferential statistics, let's look at another example. The 1948 baseball season. In 1948, the Washington Senators played 153 games, winning 56 and losing 97. They finished 7th in the American League and were led in hitting by Bud Stewart, whose batting average was 0.279. So for all those numbers, actually we try to describe a situation. And again, in descriptive statistics, the statistician tries to describe a situation. Let's look at the other area for statistics, inferential statistics. Inferential statistics consists of generalizing from samples to populations, performing estimations and hypothesis tests, determining relationships among variables, and making predictions. So before we look at the details or more examples about inferential statistics, let's look at the definition for those terms. What is a variable? A variable is a characteristic or attribute that can assume different values. Or we can say a variable is something of our interest that can vary. Data are the values, measurements, or observations that a variable can assume. Variables whose value are determined by chance are called random variables. And for random variables, we'll look at more detail when we reach to the discrete distribution chapter. A collection of data values forms a data set. Each value in the data set is called a data value or a data. For example, we can look at the average height for SHSU students. So height is then considered as a variable because by the definition, a variable is something of our interest. Height is the interest now that can vary. So we can collect a lot of height information from different individuals. And that collection forms a data set. And each value in that data set is called a data value or a data. Now let's look at population. A population is the entire collection of individuals about which information is sought. So if we want to look at the average height for SHSU student, then all SHSU students forms this population because it's the entire collection of individuals. And a sample is a subset of a population containing the individual that are actually observed. So we can, among all SHSU students, we can collect a sample. Then that subset is actually much less than the population. And then again, we call that a sample. Let's look at this example. Statistical study. We want to know the average height of all SHSU students. Total number of students, we have 21,732 based on the 2018 information. So what is the population? What is a possible sample? And why do we need a sample? So the population, we already discussed that when we introduced the definition for population and sample. So population is the all SHSU students. And a possible sample, we want a subset which is not as large as the population. And that can represent the population well. So we can say all students taking stat or math 3379. So we treat that as a sample. So this is a clear subset of all SHSU students. So no problem. It is a possible sample. And we have 35 students for each section. So we have about 700 to 800 students for this sample. So it's a good size. Why do we need a sample? Because census is almost impossible. So census means obtaining information for the entire population of interest. So we want to know the average height of all SHSU students, but survey every single student is almost impossible. There will be issues that some student cannot be reached, and there's some student that don't want to share the information, and there's student that choose to opt out from the survey. So there's a lot of reasons why that we say census is almost impossible. So then we need to collect a sample and let the sample information represent the population information. And we have to be careful when we choose a sample. We want the sample to be randomly chose from the entire population, and we don't want any bias. For example, if we look at the height and then we choose all the samples from a men's basketball team, then it'll be overestimate when we use the sample represent the population information. Okay. Again, this is the relationship between population and sample. Population, all individuals, and sample is a subset. And we want this subset to be as random as possible, so no bias there. And we'll talk about a little more. We'll talk a little more about the bias definition when we reach section 1.4. Okay, and for inferential statistics, statistician analyze the information obtained from a sample to make inference or draw conclusions about the preferences of the entire population. Inferential statistics provides method for drawing such conclusions. Okay, now we finished the inferential statistics part. So now let's go back. For this semester, we have a total of 11 chapters. So chapter 1 is more like a introduction. In chapter 2, we have the graphical way to describe data. In chapter 3, we have the numerical way to describe data. In chapter 4, we want to describe bivariate data. So these 4 chapters, they are about descriptive statistics. And then for inferential statistics, we have chapter 8. Confidence interval. We have chapter 9, hypothesis testing. We have chapter 10, two-sample confidence interval. And we have chapter 11, two-sample hypothesis testing. So these are about inferential statistics. And in between, what connects the descriptive statistics and inferential statistics. So in between, we have the MathStats. So that's chapter 5, 6, and 7. So 5, probability, 6 discrete distribution, 7 continuous distribution. Okay, so that's the structure for the whole. Okay, for this video, let's stop here, and then I will record another video starting with section 1.1 sampling. Thanks for watching.